By the midpoint of the Second World War, Germany was rapidly losing control of the skies, both over occupied territories and within its own borders, where Allied bombers were inflicting increasing devastation. Though short on resources, the Germans were not short on ambitious and often impractical ideas to turn the tide. Companies and private individuals alike submitted a wide array of proposals, some innovative, many utterly unrealistic. One of the more unusual concepts came from the Blohm and Voss company. Their idea involved developing inexpensive lightweight gliders that could be modified into makeshift fighter aircraft intended to intercept Allied bomber formations. Though the proposal bordered on the absurd, it nonetheless received official approval to proceed. Unsurprisingly, the project never advanced beyond the prototype stage. By 1943, the Luftwaffe was under immense pressure. The relentless increase in Allied bombing rates, especially those targeting Germany's industrial heartland, was pushing the German Air Force to its breaking point. Despite ramping up fighter production, the numbers were still insufficient to counter the growing aerial threat. Luftwaffe officials began searching for alternative solutions, hoping for a breakthrough idea that could tip the balance of the air war back in their favor. One concept that gained serious attention was the use of small, inexpensive interceptors. The Messerschmitt Bf-109, though relatively affordable to produce, as proven by the tens of thousands built, still required significant resources. Even so, there was growing interest in finding an even cheaper alternative. Amidst a flood of proposals, one particularly unusual and unexpected suggestion surfaced, offering what some hoped might be a low-cost answer to a high-stakes problem. Richard Vogt, the chief designer at Blohm and Voss, suggesting modifying a small glider to serve as a fighter interceptor. Vogt's rationale was rooted in extreme cost-cutting. By simplifying the aircraft to its bare essentials, Germany could produce large numbers quickly and cheaply. In theory, a glider-based design would bypass the need for engines, fuel, and other increasingly scarce materials. Of course, this entire concept began to unravel once you considered the logistics of getting the glider airborne in the first place. Since it was unpowered, it would need to be towed to altitude by another aircraft, a process that required the towing plane to reach sufficient height before releasing the glider. While obsolete aircraft could potentially be used in this role, a more modern and capable design would be far more reliable, which somewhat defeated the project's core aim of saving resources. Furthermore, the glider's lack of an engine meant it had only a brief window of opportunity to engage enemy bombers, after which it would be left highly vulnerable during its descent. Whether Vogt overlooked these drawbacks or simply chose to ignore them, he submitted his proposal to the Reichsluftfahrtministerium or RLM, the German Ministry of Aviation, in mid-August 1943. He presented it as a cost-effective solution that would avoid the use of critical resources and could be assembled using unskilled labor. He even argued that the pilots required for the glider would only need minimal flight training. The operational plan called for the glider to be towed to an altitude of around 6 kilometers by a Messerschmitt Bf-109G. Once released, it would dive towards incoming enemy bomber formations and open fire with its two 30mm cannons. If conditions allowed, a second attack run could be attempted. Upon completing its mission, the pilot was expected to glide back to a nearby airfield. The aircraft's small size and armored cockpit were intended to offer at least some protection for the pilot during this highly risky endeavor. The glider fighter was initially designated as the P-186, but this was later changed to PV-40. After reviewing the proposal, the Reichsluftfahrtministerium responded in late October 1943 with a request for 6 prototypes to be constructed. Interest in the project quickly grew, and this number was increased to 12 in December, then again to 20 by February 1944. If the design met expectations during testing, the RLM intended to ramp up production significantly with a projected output of around 200 units per month. The PV-40 was a partially armored mixed-construction glider fighter with simplicity and cost efficiency at the core of its design. Its narrow 0.7-meter wide fuselage was primarily made of wood, while the cockpit was equipped with modest but deliberate armored protection. The front of the cockpit featured 20mm of armor, the sides 8mm, and the bottom 5mm. A 120mm thick armored windshield was also fitted to shield the pilot from incoming fire. Despite the PV-40's stripped-down nature and minimal cost, the inclusion of armor demonstrates that the Luftwaffe had not yet descended into total desperation. Even in the war's final stages, considerable thought was given to the survivability of the pilot. To further reduce the target profile and improve forward visibility, the cockpit was designed to be as compact as possible, forcing the pilot into a prone position. While this configuration had benefits including a reduced silhouette and excellent frontal view, it came with notable drawbacks. Extended flights in a prone posture were physically exhausting, and more critically, the pilot had no rearward visibility, a serious flaw for an aircraft expected to engage enemy bombers which often appeared with fighter cover. This concept had been explored previously in experimental aircraft such as the AK-Flieg Berlin P9, which is covered in a separate article. However, the prone pilot layout was never widely adopted and remained a curious footnote in aviation history. Inside the cockpit, only the most essential flight instruments were installed, in keeping with the aircraft's minimalist design. Due to the high-altitude operational profile of the PV-40, the pilot was equipped with an oxygen supply system and a parachute. For additional protection, the side windows featured sliding armored screens with integrated visor slots, allowing the pilot to see out while minimizing exposure. The wings and tail assembly were largely constructed from wood, a material both abundant and cost-effective. The tailplane had a span of 1.75 meters. As a glider, the PV-40 lacked a conventional landing gear system. Instead, it relied on a jettisonable wheeled trolley for takeoff, which was released once airborne. For landing, the aircraft utilized a simple skid mounted beneath the fuselage, allowing it to return to base without requiring complex or heavy equipment. The glider was armed with a pair of 3cm Mk108 cannons mounted at the wing roots, delivering impressive firepower for such a small aircraft. These cannons were capable of inflicting devastating damage to enemy bombers. However, the glider's compact dimensions meant that each weapon could only carry 35 rounds. Ammunition was fed through a simple system. A rectangular feed hatches located mid-wing channeled rounds through internal conveyor chutes directly to the cannons. An alternative armament layout proposed replacing one of the Mk108s with a 30-kilogram towed guided bomb. This weapon was intended to be directed toward enemy bomber formations and detonated at a safe standoff distance. However, real-world testing revealed that guiding the bomb accurately was extremely difficult, and the concept was eventually abandoned. Several other weapon configurations were also explored. One suggested fitting R4M rockets beneath the wings, while another proposed adapting the PV-40 for anti-shipping operations, potentially arming it with torpedoes or 250-kilogram time-fused bombs. Ultimately, these ideas proved impractical due to weight limitations and the inherent constraints of the glider's design. The first PV-40 prototype was completed in early 1944. Although it was originally designed with an armored cockpit, initial flight tests were conducted without this feature. The aircraft's maiden flight at Hamburg-Finkenwerder was unsuccessful as it failed to take off. A more promising test flight occurred between May 6 and 20, 1944. Interestingly, another unusual Blohm and Voss aircraft was reportedly involved in these trials, possibly the asymmetrical PV-141, though some sources claim it may have been a Messerschmitt Me-110 heavy fighter instead. After these initial flights, modifications were made to the glider's jettisonable landing gear. However, tragedy struck on June 2, 1944, when the first prototype crashed during a landing, resulting in its loss. A few days later, the second prototype took to the skies for its first test flight, during which it reached a dive speed of 600 km per hour. Its fate after this flight remains uncertain, so it was most likely scrapped. The third prototype was used exclusively for static structural testing and never flew. The fourth prototype was also lost during its maiden flight, though the exact date is not known. On July 6, 1944, the fifth prototype completed a successful first test flight. Like the others, however, its subsequent history is largely undocumented. The sixth and final prototype, which featured a redesigned fin section, flew for the first time near the end of July 1944. During these trials, the PV-40 managed to reach a maximum level flight speed of 650 km per hour, Dive tests produced even more impressive results: 850 km per hour at 4,000 meters, 700 km per hour, and a remarkable 900 km per hour at 5,000 meters. Despite these performance milestones, the PV-40 ultimately failed to meet expectations in terms of flight performance and practicality. After a comprehensive evaluation by RLM officials, the PV-40's major shortcomings became undeniable. The aircraft was found to be highly vulnerable to Allied fighter cover, which would make any operational use extremely risky. Reports from the prototype test clearly revealed that the concept behind PV-40 was fundamentally flawed, leading to its cancellation in mid-August 1944. In the following month, Allied bombers effectively wiped out the remaining 14 PV-40s, which were at various stages of production. Despite this, Richard Vogt and Blohm and Voss team made one last effort to salvage the project. They proposed adding either 2 pulse jets or 2 rocket engines beneath the wings to improve aircraft's performance. Unfortunately, these proposals did not lead to success, as other experimental designs such as the ME-328 and the ME-163 showed more potential but ultimately also faced failure. On paper, the PV-40 seemed like a promising concept, boasting several appealing qualities: ease of production, the potential for mass availability, affordability, effective armament, and the ability to operate with minimal training for pilots. However, once put to the test, its performance revealed major flaws. The glider lacked a power plant, had limited ammunition capacity, and would have been highly vulnerable to Allied escort fighters, undermining its effectiveness in combat. These critical drawbacks led RLM officials to cancel the project, marking the end of the brief and ill-fated venture into German armored glider fighters. Despite the failure, one positive aspect of the PV-40 project was that it was actually built and tested, unlike many other proposals at this stage of development that never made it past the drawing board. This concludes our look at another unusual German aircraft proposal from the Second World War. What are your thoughts on using a glider in the role of a fighter interceptor? Feel free to let us know in the comments below. If you're interested in exploring more bizarre and unique German aircraft design, visit our YouTube channel for more. If you like what we do and want to see more, remember to subscribe so you don't miss a single video. Also, don't forget to take a look at our extensive collection of articles on our website plane-encyclopedia.com. Thank you, and see you next time.